Hello friends, welcome to FreeCAD tutorial, and in this tutorial we are going to do FE analysis in FreeCAD with the help of a FEM workbench in FreeCAD, and we will do the analysis of this L-shaped joint, and we will study its deformation and stresses in FreeCAD. You can also visit my website mechnexus.com, where I write articles and tutorials on FreeCAD. You can also download my tutorial source file from here. You can also support my work by buying my FreeCAD crash course for beginner. It is a very basic level course for the beginner user, where a beginner user can master the FreeCAD. And you can also support my work on coffee.com. You can buy me a cup of coffee. You will get my website link and my Ko-fi donation page link in a video description. I will close this file and I will show you from the scratch how you can do the same FE analysis which I have did in FreeCAD. Now I will create a new file, and I have activated part design workbench. I will create my body on my origin plane, and on this plane XY I will create my part. I will of the origin plane I will select the polyline tool and create my L-shaped part. Now I will make this vertical, this and this horizontal, and this will be the vertical. Now I will give my dimensions 100. This one will be the 100, and this one will be the 30, and now here I apply the fillet, and I will give it 5 mm. Now I will close my sketch and I will click on the pad tool and I will give it a thickness 5 mm. Now on this face I will create 2 holes. I will project the edges. Now I will give the dimension 30, and this 115, I will give this and this 15, and this and this 30. Now I will give this diameter 15 mm, and I will make this and this equal. Now I will click on the pocket tool and remove the material. Now our part is ready for the FE analysis. So we will switch to the FEM workbench. Now here on the FEM workbench, first we will create a container for our analysis, where we apply the material, create the meshes and run the results. So on here you will get an icon known as the analysis container, and our next step is to apply the material to our body. So I will select my body and click on material for solid. So here I will select my material. So in my case I am going to select the steel IC45. So once you select the material, you will get its properties. So density is a 7800, which means that the steel IC45 is a carbon steel. Or I can select some density up to the 7850. Let's see. Steel, okay, this is the better material of density 7900. Now I will click OK. Now we have applied the material. Now we will apply the forces and we will fix our part at one end. So this hole will be the fix. So here you will get the icon constraint fix. Click on add, select the face. So you can see that fix symbol has been inserted. Say OK. Now we will apply the forces. Fix means that this hole is fixed either with a bolt or any other method, either maybe it will be welded. So this is the fix and we will apply the forces. So to apply the forces, you will see one icon here, constraint forces. Click on it, click on add, select the surface. So now you are seeing the force direction on the right hand side. If you want to reverse your direction, just click on reverse direction. So you can see that arrow has been reversed. But I wanted to apply the forces on this direction. So click on OK. Now next step is to apply the mesh. So in FreeCAD FEM Workbench we have two types of the mesh. If we select our body, we can see here two mesh. First one is a FEM mesh from NetGen and second one is a G mesh. So we will go with the NetGen. So we will click on it and here max size and second order we will tick mark it. So on max size we will give the 5 and the second order is the more precise. Let me explain with the images. So this first one is a first order and we see only 4 nodes, but on the second order is a tetrahedron elements and we see number of nodes are more as compared to first order. So in FE analysis, more finer your mesh, more precise result you will get. So we will go with the second order and click on the apply. So you can see that mesh has been created. Triangular count is a 1230 nodes and other value is given here. So tetrahedron count is a 1535, which I have shown this one. So we will click on OK and here we are seeing the blue tick mark. So we will click on refresh. Now we have model our body, we have apply the material, we have applied the forces. So in forces here I forgot to apply the load. So load I will apply 500 Newton. Click on OK. Now we will move to the next step, and next step is our solving stage. So here on FEM Workbench you will get an icon of a solver. Click on it and now you can see that solver has been added. Double click on it. So our analysis is a statics, so we have selected statics here and click on write INP file and write is completed and then run on calculus. So our calculation is running. So once you get this message, calculus done without an error, which means that our result is ready. Close it. Now to see the result, double click on the calculus results. So here is our results. Now we will read the results, and what are the results are showing here. First one is a displacement. So we can see that max displacement is a 75.75 micron, and here is a displacement factor. So displacement factor we will keep 5. So 5 means that it is a 5 times more displacement than its actual size. So if we increase our displacement, so that you can see that how part is deforming. So we will keep it up to the 5 times. So this is the displacement, and you can also get here von Mises stress. If you click on it, so you can see that stress is acting. You can get other factor as well, like displacement in x, y and z directions, maximum principal stresses, minimum principal stresses, where it is acting, maximum shear stresses, like this. Now we will on our body. Now click on the calculus results and click here post pipeline from results. So you can see that a graph has been inserted here. Now click on result pipeline and click on here wrap filter. On here wrap filter, mode is a surface, field is a displacement. We are more interested in a displacement. Click on apply and OK, and hide this CCX results. Sorry, hide this result pipeline. So now you will have the clear idea how much stresses is acting and how much displacement you are getting with respect to the graph. Now let's see what if we make the changes to our model. So here we have applied the radius of 5 mm. Now we will change the radius to the 5 to 30 mm and we will see the results again. So for this I will activate my body, go to the pad sketch, and here I will make it 30. Before that I will delete these results. So you can see that radius has been updated here. Now activate our analysis and again activate this solver and write INP file, and then run calculus. Calculus done without error. Now we will click on the results. So some graphical issue on if you see perpendicular. Now here we can see the displacement with our actual body. How it is deforming. So we will keep our factor 5. Say OK. Now click on the calculus results, click on post pipeline results, then click on post pipeline result and click on the wrap factor, and again in field section select the displacement and say OK, and hide this result pipeline. So you can see that our new result with a modified radius has been updated, And this FEM workbench is very pretty handy, and you can change the shape, you can change the material, and you can do multiple calculations based on the shapes and material in FreeCAD FEM workbench. So this is a very simple tutorial on FEM workbench of a L-shaped joint. In future I will take some more complex FEM analysis. Till now you can practice this with the help of FEM workbench, and I will provide the source file in a video description so that you can practice it. And also visit my website mechnexus.com for articles and tutorials on FreeCAD. I will come with more useful tutorial like this. Thank you for watching, and thank you for your valuable time.